Hi everybody. This video is going to cover the lesson 6 notes, which are on pages 36 to 37 in your notes packet. And for today, our target is I can calculate the derivative of, and here we're really focusing on exponential and logarithmic functions. So exponential and logarithmic functions are going to be the focus of today. And really this is going to come down to another set of rules that you're going to have to memorize so that we can take derivatives of functions. So the first category we're going to talk about is derivatives of exponential functions. And when we say exponential functions, we're talking about something like this. F of x equals a to the x. And this is just where a is a constant or a number. So we have some number raised to the power of x. That's an exponential function. And so when we have something like that, our derivative, f prime of x, is going to be a to the x. It's going to start out just the same. And that's going to be times the natural log of a. And that'll be our answer. So in this example, we have f of x equals 3 to the x. Our derivative f prime of x is going to be 3 to the x times the natural log of 3. Now, we have another function, f of x equals e to the x. And this is really just a special case of our general exponential function. Remember that e is just a number, right? E is approximately, I think it's 2.718. So in this case, our a from our previous example is 2.17 or 2.718 or e. So if we're going to take our derivative and we follow our previous pattern here, well, our a, I'm going to make a note here. This is really our a. Our a is e. So we have e to the x times the natural log of a. Well, for us, that's e. But one thing we need to know here is the natural log has a base of e. So when we take the natural log of e, right, we're really saying e to what power gives me e back? Well, that's just 1. Natural log of e here is just equal to 1. So really our derivative is e to the x times 1 or just e to the x. So e to the x is actually a nice case here. And I'm going to put this in a box so it's really clear. E to the x, its derivative is just e to the x. So if I have a problem here, f of x is e to the x, the derivative is just e to the x. But it comes from that same rule that we used for our derivative of a general exponential function. All right, so let's look at some examples here, and we're not going to do all of these. We'll probably just do 1 through 4 and then talk about 5 and 6 when we're in class. So let's look at number 1. So we have e to the 3x here. Now we have to be a little bit careful. When it's just e to the x, we can just use our regular rule for exponential functions. But because I have e to the 3x, that means for this problem, we have to use chain rule. So our outside function is our exponential, our e, and our inside is that 3x. So our derivative is going to go like this. Well, we know the derivative of an exponential is just itself. So we're going to start off with e to the 3x. And then we're going to multiply by the derivative of that exponent. So the derivative of 3x is just 3. So our answer is just going to be 3 times e to the 3x. And again, that's because we have that chain rule piece there. For number 2, we have f of x equals 5 to the x. So in this case, our a is 5. So we're going to use that first rule that we had. So f prime of x is just going to be 5 to the x times the natural log of 5. Let's see, for number 3, we can see we've got a couple things going on here. So first of all, we have that constant multiple rule because I've got the 5 out front. So I'm just going to take 5 times the derivative of e to the negative x. But again, because it's e to the negative x, we have to remember that we have to use our chain rule here. So let's see what we get. We're going to have g prime of x is equal to 5 times e to the negative x. Well, we're going to start off with, it's just e to the negative x, but then the derivative of negative x is going to be negative 1. So our derivative is negative 5 times e to the negative x. All right, and number 4. So now we're using our derivative for exponentials, but you can see here, again, because this exponent, it's not just x, it's a function of x, this is going to require us to use the chain rule. So let's see how this goes. We have y prime equals, well, our rule starts off with just a to the x, so we're just going to have 4 to the 2x minus 1 times the natural log of 4, but then I have to multiply by the derivative of that exponent, which the derivative of 2x minus 1 is just going to be 2. Now it's really important to notice here, there's nothing I can do to simplify. I cannot multiply that 2 with the 4 because 4 is the base of that exponential function. So there's nothing else I could do to simplify that function. All right, so we'll leave 5 and 6. You can see there's some other rules going on there, so that'll be good practice to get us started when we're back in class together. So let's look kind of at our last set of rules here. Now we're going to talk about the derivatives of logarithmic functions. So if I have a function f of x equals log base a of x, my derivative is going to be 1 over x times the natural log of a. So if we look at our example here, f of x equals log base 3 of x, our derivative f prime of x is going to be 1 over x times the natural log of 3. So now we have f of x equals natural log of x. And again, this is kind of a specific case of our first rule. In this case, natural log is just log base e of x. Let me write that a little bit different so it's a little more clear what I'm saying there. So this is equal to log base e of x. So if we use our first rule, we would take 1 over x times the natural log of our base. Well, our base here was just e. And if you remember from the previous page, we said, well, natural log of e, right, that's just equal to 1. So actually our derivative just simplifies here to 1 over x. So the derivative of the natural log of x is just 1 over x. So in our example here, you can see we've got 3 times our function. So we're going to use our constant multiple. My derivative here is going to be 3 times the derivative of natural log of x, which is 1 over x. And so we just get 3 over x. And again, we'll probably do the first 4 problems here and then save the rest for when we're back in class. So let's take a look. In number 7, hopefully by now we're starting to recognize we have natural log of something that's a function of x. It's not just x. We have 3x in here. That's going to require chain rule. So our derivative of y with respect to x, let's see, we're going to use our normal kind of derivative for natural log, which says take 1 over the stuff inside the parentheses, so 1 over 3x, and then multiply by the derivative of what's in the parentheses, which is going to be 3. And so here we actually have our 3's cancel out, so our derivative is just 1 over x. Number 8, this is just a straightforward application of our derivative of logarithmic functions. That's going to be 1 over x times the natural log of our base, which is 5. Number 9, we can see we've got natural log again, and because what's in parentheses is 4x plus 5, we're back to our chain rule. So we're going to take our derivative for natural log says take 1 over that stuff in parentheses, 1 over 4x plus 5, and multiply by the derivative of that inside, which is going to be 4. So we get 4 over 4x plus 5. And the last one for us will be number 10 here. So let's see, we have a log here, okay? And if it is not noted, right, we know that log, this is going to be base 10. So what we have here, p prime of x, well, my derivative for logarithmic function says take 1 over, we're going to take that stuff in parentheses, and then we're going to multiply by the natural log of the base, and then we're going to multiply by the derivative of the inside. Again, I should have noted here, this was chain rule. So the derivative of my inside is just times 2. So I'm going to get 2 over 2x minus 1 times natural log of 10. Now, it probably looks tempting to cancel something because I see a lot of 2's or factors of 2, but here we can't cancel anything. This is as simplified as we can go. All right, so hopefully these should be pretty straightforward. The biggest thing is just memorizing the rules. I highly recommend making flashcards and testing yourself. Again, as we move forward, it's going to be really important that these derivative rules are just automatic to you. It's going to make your work a lot more efficient as we go forward with derivatives and ultimately into integrals. All right, thank you for watching, and I will see you back in class.